Hello everyone, welcome to class. This will be our final video of the semester. So it's been the semester's gone by really fast. I hope you guys have had a good experience in the class. I've been really happy with the progress we've made. I think doing some code initiatives, taking a couple projects and putting them on GitHub is a really valuable experience. And I'm really looking forward to seeing how you guys have progressed with your personal projects. Now, the video I'm going to do today, I'm going to be sharing some other tips and things you can do on GitHub, basically as suggestions in the future. Now that we've done some work and we're more familiar with GitHub, although some of you have been previously, a few things that I like to do on GitHub and that I'm aware of. One of them is basically browsing other people's projects and seeing other projects that are similar to yours to get some ideas on how to improve your code. And that's something that is really valuable. And for example, with Connect 4, it happens that there's a lot of really neat projects on GitHub. Some really advanced Connect 4 projects. And I'm going to show an example of that. I'm also going to be doing a slight upgrade to the Connect 4 project based on some of the things I find on other GitHubs. I'm going to talk briefly about a process called forking another repository. And essentially on GitHub, if you see a code repository that you are interested in, you have the option of forking that repository. So essentially what you're doing is you're creating a copy on your GitHub of that repository. And there's sort of two purposes you can use that for. You can use that to then basically start developing something based off of the code that's already been created. Or you could make some changes and submit a pull request to the original author to help contribute to their project. So both of those are quite interesting. Anyway, in terms of what we have to finish up for the course, this Wednesday I'm looking to get your personal projects submitted, and I need to have all fixes to the resumes completed by then. So with the resumes, I am going to be going back and I'm going to continue to make edits and basically provide feedback and have you fix up your resumes. With resumes, one of the things that we need to take away from this is that a resume needs to be perfect. If you hand in an 8 out of 10 or a 9 out of 10 resume for a job interview, and in other words, it has one or two issues, maybe a typo here, maybe some bad formatting here, we know that the resume is going to get thrown out. So the resumes have to be perfect. All right, so I'm not looking for you guys to spend a lot of work, a lot of time on them, but please take the feedback I've given, make the fixes that I suggest, and then resubmit for at least by Wednesday, because I need to submit the marks at that point for the course. As well, make sure that your personal project is complete by then also. Okay. So let's get into the GitHub, and we'll take a look at some different things there. And I'm going to work on the Connect 4 project today. All right, so I've got my D2L shell displayed here, and a couple things I want to point out. One of them is I found a really good video for Git, and this video kind of basically I think it's a good video for you guys to look at. Now that you have some experience with Git, I think that this video will sort of help you take your next steps in improving your skills. It also has a link to a free book related to Git that is pretty much an industry standard book. So that is a great link. And there's actually a video series that comes with that video, where they're going through a whole bunch of different tools and techniques that are really important to a career in software development. So I recommend you guys check that out. And the other thing, as I was mentioning about different GitHubs and such, basically I went and I found some different GitHubs. I was searching, and there were a few that were related. I found a bunch related to Connect 4. So for example, if I go and search Connect 4, all of GitHub. Okay, you can see there's all kinds of different, there's hundreds of Connect4 GitHubs, and that's kind of a neat thing. I mean, it makes sense because Connect4 is a fun game and it's fairly easy to program. So in terms of doing a simple game project, Connect4 is a pretty solid one to start with. Now the one that I found that I was really quite interested in is this website here, and this is related to a GitHub repository as well. But this person has created a website where they've gone through all these different techniques, and they're basically teaching you how to set up your own Connect4, and the resources are great. One of the things that I found really fascinating about this is that because computers are now fast enough, they can solve Connect4. And it turns out that Connect4, the player that moves first, if they play perfectly, they will win every time, which is pretty neat. Like you wouldn't know that unless you put a lot of effort into learning this. And so just to read this here, Connect4 is a strongly solved perfect information strategy game. The first player has a winning strategy no matter what the opponent plays. Initially, the game was first solved by James D. Allen on October 1st, 1988, and independently by Victor Ali two weeks later on October 16th, 1988. So these two people, they used basically mathematical solutions to do this. They didn't actually brute force the technique I'm kind of proposing, where you create a massively large search tree. But they were able to solve the game. When computers became faster, though, in the 90s, then people started solving it with basically using their computers. So basically, there's a tutorial here, and it goes through all these things. So the min-max algorithm, that's what I'm going to be implementing today. All right. And so basically, the way I described it is you alternate turns, and basically each player makes a move, and they check to see if there's a game over condition after they moved. And they may have won the game, or it might be a draw, essentially. And those scores then get returned up the tree, this massive, large search tree. And this might be one of the first cases where you guys will be exposed to what's called a recursive algorithm. The function I'm going to write, the search function, it calls itself. So basically, when it's red's turn to move, it's going to make all the moves, and then it's going to make one move, and it's going to call search. And then yellow's going to make all their moves. It's going to call search. And whenever a function calls itself, this is called recursion. And this is a strategy that you'll come across every now and then. So in this type of situation, recursion makes your code a lot easier to write. Okay, so I'm actually going to be using the NegaMax variant. And I recommend you guys go through and take a look at this, but they're showing here the code for setting this up. This is the NegaMax function. And the nice thing is it's really, really succinct. So here's NegaMax. This is really small, actually. I wonder if I can... It's gonna be too big. Okay. So here's the entire function. And you can see here, it calls NegaMax. It passes in a position. And it loops through all of the moves. And basically, okay, no, here's where it actually loops through the moves. And it makes the move, and then it calls NegaMax again. All right, so that's the recursion. And notice it takes the negation. It basically negates the score that the other player makes. So even though one player is min, one player is max, if they each negate the other person's score, they can both basically use the same code where they're trying to maximize the score. So NegaMax it's an extra complication, but it means you have to write a lot less code. So I'm gonna add NegaMax to my Connect4. And you can see there, it's not much code. The only issue I have is that I wrote my code without sort of thinking about this. So I do have to do a bit of cleaning up first to get this working. All right, so let's open up my Connect4. Okay, so the changes I'm going to be doing for the Connect 4 project, these are going to be related to adding what's called the NegaMax algorithm, okay? So right now the AI that we have is very, very basic. It'll basically look for a move where it can win, and it'll look to see if there's a move that the opponent has where it could win, and it'll try to block it. Otherwise, it makes a random move. So to make it play at a higher level, the first step is to add what's called the NegaMax algorithm. Sometimes this is also called the min-max algorithm, okay? And basically, the way it works is you have a board position, okay? This is your Connect 4 board. And the red player, it turns out, goes first. So the red player is going to then go, and they are going to make all of their moves. So you can look at this as there's basically 7 positions where they can then make a move, okay? And these would be their boards, okay? And you can see the position there of one of the 7 columns is selected. Now for each of these moves made, now it's yellow's turn to move. So this is basically red moves, and now it's yellow's turn to move. So for each of the columns, yellow is now going to make a move, right? Oops. And so on and so on. So there's going to actually be 7 nodes that yellow is going to make. And basically what this is a search tree, and it gets very, very wide as soon as we start to traverse down in the tree, all right? Now, in the game of Connect 4, it turns out there are only 42 positions, okay? Because there's 7 columns, 6 rows. So that is 42 positions on the board. So basically, from the moment that red moves, the tree can only go to a depth of 42, all right? And at that point, the game is either won, lost, or drawn. And at any time, one of the other players can win. So basically, what the NegaMax function does is it searches in basically a depth-first fashion, where it makes all of the moves for one player, then it makes all of the moves for another player, and it alternates back and forth. In addition to that, it also assigns a score for each of the moves. Now, Connect 4 is a fairly simple game. So basically, the score it can assign is 0 is a move that doesn't win or lose, okay? If the red player wins, then you would assign a positive score. So if red wins, let's say a red win is worth 10, okay? And if yellow wins, that would be negative 10. So essentially, Connect 4 is what is considered a zero-sum game, all right? For red to be winning, that means that yellow has to be losing. And if yellow is winning, red is losing. And if you basically take the outcomes and add them together, you end up with a score of 0, all right? Now, the way I've shown this, with 0 as a draw, 10 as red wins, negative 10 as yellow wins, this would be what's called a min-max algorithm. Essentially, red is what's called the max player. So they are trying to maximize their score, where yellow is what's called the min player. They are trying to minimize their score. Now, a slight modification to this algorithm, instead of doing min-max, there is a modification, an enhancement to it called NegaMax. In other words, each of the players tries to maximize their value, and they negate the value of their opponent. So by doing this NegaMax, what we're essentially doing is we're simplifying the code that we have to write, that both players try to maximize their score, and they take the largest score of the negation of their opponent. Now that's probably a little bit confusing, but that's why we're going to go through and do this code example together. And there's also lots of documentation on the web. These are common techniques that are used for playing games. All right. Now, before we get into actually writing any code, one of the important takeaways from the last class where we had Jin Man Chang as our guest was that we want to plan out the code we're going to write. We don't want to just sit down at the computer and just think, okay, what do we need to do here, and then just start coding. So in my case, I'm thinking about what changes I'm going to make. So essentially, I'm going to add to my code base 2 new functions. I'm going to add one called makeMove, and I'm going to be passing in a value of a column value to makeMove. Okay, that's going to be its parameter. I'm also going to make one called UnmakeMove. And I'm going to be passing it in the column I want to unmake. Now, these 2 functions are essential because in that before I cleared my board, remember, we had basically the search tree where I drew all these nodes, all right? And in order for us to be able to perform this search where we move from one position to the next and down and then back up and over and we traverse this search tree, we need to be able to make moves and unmake moves efficiently and simply on the board. So these 2 functions are going to be very, very important. The other changes I am going to make, I'm going to have to make a few modifications to simplify some of the code. So for example, I have a function called checkWin, and I pass it a bunch of parameters. I'm going to have to modify it so I'm just passing it in the column where the last piece was placed. Right now I think I'm passing in the player and also the row where I place that piece. So I'm going to modify the checkWin. I'm also going to have to add a new function, and this function is going to be called search. And it's going to take in one parameter, and that is going to be a depth parameter. I'm going to call this depth to go. So essentially, when I'm at this node up here in my tree, I'm going to pass in, so I'm going to call search, and I'm going to pass in this parameter depth. And let's say I pass it a depth of 3. That means that my search algorithm is going to search to a depth of 1, 2, 3. Position. So it's going to look at the entire search tree 3 positions ahead. Now 3 is just an example. I could pass in a larger value, and obviously then I'm going to search deeper down in the tree, and I'm going to come up with a better solution. Now you might be saying, well Eric, why don't you pass in a search of 42? Or basically search till the end of the game. And potentially we could. The only issue there is that we would potentially run out of time. The code that I've written won't probably execute fast enough to be able to search all the way to the end of the tree. If you could do that, and it is possible, if you could search and not limit it based on a fixed depth, you would be able to play perfectly, which is kind of neat. One of the things I like about programming this and using computers, the idea that you can actually solve this game and play perfectly. Okay, so I'm going to add that. I'm going to also make one other change. Right now, when you play the game and you finish, the pop-ups are covering the board. So I'm also going to place pop-ups below board. Okay, I'm going to be creating a new branch on my local Git account, and I will do all this work on the branch. When I'm done, I will then do a pull request on my Git remote, and then I will merge that pull request into my GitHub repository. Okay, let's get started. And let's just run this just to see what we have. Okay, so that's as I remember it. I play and then the computer plays, okay? And one of the neat things, because we already have some AI already in the game, once I add the NegaMax, which should be a much more powerful AI than what I have, I can actually have my game simulate and play against itself to see which version of it is stronger. All right, now a few things I wanted to do for a while. I wanted to use the use strict, because because I never did actually do that, and I should have that there. I closed my browser there, okay. Okay, and now of course right away I have an error, and that's why we use strict. So end pause is not defined. Okay, so what do we have here for end? Okay, so I called it end post. So that's why you put in use strict, because these type of errors, typos like this, can really cause problems with your code. Okay, that looks better. All right, and looking at my whiteboard, you guys can't really see it, but so I'm basically going to clean up some code first. So right now I have check win. Where's check win? And I'm passing in the row and the player, but I don't need the row and the player because I know that whatever piece I just dropped, that's the one I want to check, and that'll be the one that's the highest up on my in my game board. So I can get rid of that. And I'm now going to figure out which row I want to check. Okay, so I wrote a check. Okay, so I'm going to say let row equal, and I need to basically loop through the column, and I need to select which is going to be, which piece is highest up in that array. Okay, so I'm going to say let row equal 0, or let I equal 0, I less than 6. If board column I equals, is not equal to 0. So in other words, if a piece has been placed there, then I want to say row equals I, and I want to break out of my for loop. Okay, so that should fix that. And the other one that I was passing in was the player. Okay, so player is right here, but I do not want to use that. So I want to say let player to check equals, and I'm going to basically get the position in the board. So board column row, that's going to be the piece that was placed. So it's either a piece of player 1, which is yellow, or it's a value of player 2. Okay, so everywhere I used player, I need to change that now. So player's here, I'm just going to change that to player to check. Okay, looks good. Okay, I think I got it. So I'm just gonna run this again, make sure I haven't completely broken it. Okay, looks good, yep. Okay, now the next thing I wanna do, I don't like how these two pop-ups are covering my board, so I'm gonna place them lower now. So I'm gonna go down to where my canvas is, and I'm gonna change this, I'm gonna add 300 pixels. So that's 926 is now the lowest point. And that means when I do my draw function and I clear my canvas, I need to make sure I'm clearing the whole thing. So there we go, I changed that. And I'm now gonna add some values to this. So instead of 200, I'm gonna draw this at, let's say 7, and let's say I go with 800 for this. So 700, 800, I'll have to test this out and make sure it looks okay. And we'll go 750 for this one. Actually, no, we should go 800. Just keep it simple. And now where I actually process the input, I'm gonna go up to where I'm selecting, I'm taking input here, and that is get mouse position. So I want for y greater than or equal to 800. What was that before? So that was, okay. So that is going to be 899, I think. Okay, let's try a game. Okay, so red wins, but I don't see my play again anywhere. Okay, let's go back to the draw function, and it should be drawing the, 8,000? Yeah, that's why. Okay, let's try that again. I'm gonna try to win this game. Darn it. Okay, having trouble here. Okay, so red wins, play again. Okay, so that's pretty good. I mean, you could arrange it. They need to be spaced out a little bit. It's kind of ugly, but I can do that later. Okay, so we got that done. A few other small things I need to do. It turns out that red is the player that moves first in this game. So I'm going to change, instead of player equal 1, I'm going to say player is equal to 2 because that represents red in my game. And then in get mouse position, so game state is playing and player equals 2. So now when I play, red is going to be the first player that moves. And I need to also modify it so that the computer player is going to be yellow. Okay, there we go. Okay, so we're making good progress. Next thing I want to do is I'm going to now add my make move and my unmake move functions. So each of these functions is going to accept as a parameter the column where I'm placing the piece. So function make move column and function unmake move column. Okay. So for make move, what I want to pass to that, the column there, so now what I need to do is I basically need to loop through that column, and I then need to add the piece to the first available spot. So I need a for loop, so for let I equals 0. 0 is going to be the top position, 1, 2, all the way down to 5 in terms of my indexes in my array. I less than 6, I plus plus. So if board column I, okay, actually, we're going to go the other way. We're going to start at 5. We'll start at the bottom, and we're going to move up. We're going to start at the bottom and move up until we find an empty space. So I greater than or equal to 0, and I minus minus. So if board call I equals 0, then I want to place the piece. Now, in terms of what color of piece, I'm just going to use the variable player. Now this should probably at the very least rename this variable. Global variables are also kind of bad. So this might not be the best way to do this, but for now this is fine, okay? So I know that that's the piece that I want. What else? And then I want to break out of the loop. Now, the other thing is, because I've just made a move, I also have to switch players. So if player equals 1, player equals 2, else player equals 1. Now, I'm almost tempted to change right now player. These numbers don't really work that well. Like every time I want to switch players, I got to do this this if-else statement. If I change the numbers, I could use some kind of like clever math trick, depending upon what numbers I pick for the players. But that's just too much work right now. So let's just go with this. So that is my make move function. And now let's do my unmake. So basically for my unmake, I start at the top now of the board, and I'm going to move down in that column until I find a piece. And when I do, I'm going to remove it, and then I'm going to switch the players. So this is going to look really, really similar to my make. It's going to be so similar that I'm going to copy it. So now I'm going to say for I equals 0, I less than or equal to, I'll say I less than 6, and then I plus plus. So I'm starting at that top piece, moving down, and if the position is not 0, then I'm going to set the position to 0. I'm going to remove the piece, and then I'm going to swap the players. Okay, so there is my make and unmake. Now I need to hook these up, because right now in my code, there's a lot of places where I'm doing stuff like this. Okay, I'm inserting code where I'm basically just modifying the board wherever I feel like it. And I can even search for these. I can just like do a quick search, and there's so many places here where I'm modifying the board. So every place where I do that, I'm going to want to change this to use the make or unmake move functions. So the places where I need to do it are in computer turn, right here, okay, where it's placing a piece. And this is also bad that it's hard coded in too, even though that might not be it could be playing as yellow there. So I should actually create another value. Okay. So let's just see the places again where I'm going to do that. So here, these two spots, I'm making a move and I'm unmaking it. I'm making and unmaking. So I need to call it there. And I need to also call it right here. And that's it. So 3 spots. Okay. So I'll comment this out. And I'm now going to call make move. And I'm going to pass this the end. And that represents the column. I'd have to go look at my end pause. But if you look here at end pause, the second value in the array, at index 2, is the column. So that's the one that I'm going to make the move with. Okay. And now we come down to here. Instead of that, I'm just going to say make move column. And then I'm going to say unmake move column. And same thing here. Make move column. And then okay, and you can hopefully you guys can see this is a much better way to use a function to do this. Without the function, I was basically sprinkling bits of pieces of code that would manipulate the board throughout my program. And that can lead to errors. In fact, the way I was doing it wasn't correct because I was making assumptions about which player was moving. So now I'm running this through a function. It means there's only one place where this code can exist. So if I have a problem with my board, not only do I have one place where I'd have to put my debug statements or debug, I can also focus where I'm looking to see where I might need to make a fix. Okay, so let's try this and see if this works. Okay, it does not work. Okay, so let's just try this again. Okay, so it dropped the piece, but then it didn't make any calls as far as I can tell to do the computer turn. So why not? Let's see, computer turn. Okay, so drop piece, it makes the move, it should switch players, but there's this extra code here that switches it back. So because, yeah, there we go. Okay, so I'll just comment this code out for now. Obviously at some point I'm gonna need to remove it, and I could probably just remove it anyway. Now I also modified the check win earlier. So that is a bit of an issue that you can see here. I'm still calling it with 3 parameters. Yeah, okay, that's bad. So check win should only have the 1 parameter here. So it's just ignoring the other parameters, but I should just remove them. Okay, so let's try it again. Okay, there we go. All right, so it seems to be working fairly well. So now we're at the point where we can do write the search function. So basically the search function, when we want to make a move, we're going to loop through all our moves, and we're going to then call search for each of them essentially. So I just need to find a place where I can hook this up. So after I drop the piece, this is where it comes in here and it makes the call to do the computer turn, okay? And this called my previous code that basically looked at the different positions and potentially made a move based on a few conditions. And if it couldn't find a win or a block, then it would make a random move instead. So I can comment this out, and right now what I want to do is I'm going to add my function. So function, I'll call this, okay, I'll call it NegaMax. Actually, I'll just call it search. Okay, so I'll call it search, and the parameter that I want to pass in is depth to go, or actually depth remaining. Okay, so when I start my search, maybe I give it a value of 5. Then it moves down and it makes a bunch of moves. It moves to the next level on the tree. Now it has a depth remaining of 4. Keeps going. The tree gets wider and wider. When it gets to a depth remaining of 0, it calculates a score and returns back up to the root node. And at the root node, it checks to see which is the best score. And that's how it knows basically if it's what move it should play. So at this point, I'm going to write a little bit of code here inside this where I'm going to loop through all of the columns. Actually less than or equal to 6, let's do that. And then I++, so I'm looping through all of the various columns, and I'm looking for basically, I'm going to make each move, and then I'm going to call the NegaMax function. Now, how you set up the initial, how you get into that function, you basically need sort of 2 steps. The root node needs a little bit of special handling. So you could make a start search, and then basically a search. I'm just kind of going to just generally add this code right here, and it's going to then call the search function. I can go back and restructure that later though. So basically what it wants to do here is it's going to check, can I move? So it's going to say if board at column I row 0 is not equal to 0. So in other words, if that column is full, if all the pieces have been placed, I can't actually go and try and move here. So if that's the case, then I don't do anything. But if it is 0, sorry, so it should be equals 0, then I want to actually make a move. So I'm going to say make move I, which is the column I'm in. And then I'm going to call search. And I'm going to give it, let's just say I use a depth remaining of 4. All right, so 4 moves is what I'm going to search. Now, I also need to have a score. So let best score equal, and I'll give it a large negative value. And I'm going to say let best move equal, it doesn't really matter, I'll just say 0. Okay, so best score equals math.max best score, and I'm going to basically take the larger of the max score or what's returned for me from the search for that column. Although this doesn't set my best move, so I'm not going to do it this way. I'm going to say best, I'm just going to say let score equal my search. And now I'm gonna do an if statement. So if score is greater than best score, I'm gonna say best score equals score and best move equals I. All right. Okay. So at this point, I now actually have the best move. So I can then go and actually make the move if I want it. All right. Okay. Let's see here. Okay. So right now, what I'll do is I'm just going to have search. I'm just going to have it return. Okay, math.random times 5, and I'll put a %int around this. So I'm just going to return a random amount. So it's obviously not going to play very well, but I just want to make sure everything's hooked up and it's working. So I've got that done. And now I just need to drop the piece. So I just dropped a piece. So I guess I want to call place piece. And I want to do this with my best move. Okay, let's try this out. Whoa. Okay. Okay. Slow down. So that did not quite work. So it's okay. Now, normally when I come and run up against a problem, I cut the video, right? And then I fix it and then I come back in. But I'm going to show just maybe a few steps of what I would try to do in this situation because I haven't before. So one of the things that I will do is I'll go into the sources section of the browser. And here I can set breakpoints and do some simple debugging. So basically the issue, I want to see where I'm placing pieces. So I'm going to put a breakpoint there. And now when I run this, the execution is going to stop. So the humans made a move, and now the computer player has also made a move. Okay. So I can pretty much see where this came from. So the drop timer, there was an interval set, and this called best piece. The move is 0. So yellow is going to try to place a piece there. Now, the only problem is that place piece don't think it makes an actual move. Okay. So what I can do now is I can just hit continue, resume script execution. Okay, so it did go and place the piece here, all right? So that's good, and that actually tells me, I think I figured it out. So I thought the issue was gonna be with the place piece, but that looks fine. The piece dropped here, but when you saw it drop, there were all kinds of pieces that shouldn't have been there. So I know what the problem is, and it is that I'm not unmaking the move. So when I'm testing out these moves, I try a move, I check the score, I need to unmake it as well. That way I'm back at the original position and I can keep checking my moves. So I'm gonna continue on. I don't need to cut the video or anything. So I'll remove the breakpoint and I'll just continue. And let's go back into the code. And at this point, the change I need to make is that I need to unmake the move. So where I go make move, I need to then go unmake move I. Okay, let's try running this now. Okay. All right, so math.random times 5 parse int doesn't appear to be giving me anything really interesting. Let's just try that again. Okay, so I'm just gonna do this. I'll do another debugging technique here. So another one I could use, I could just do a console log. Actually, I'll go let return. Actually, I shouldn't use return, it's a keyword. So let value or val equal, and I'll say math.parseInt math.random times 500. Return val. And now I'm going to go console.log val. And I can look in the console. Okay. So, okay, I'm gonna debug it now. That didn't really capture the numbers. I have too many debugging statements right now there. Okay, so here we go. Okay, so I step over, and I can hover over val. Oh, not a number. So what's the oh, okay, I know why. I'm just not calling math.random properly. So that's going to be math.random. Okay, so now it's making random moves. All right. Okay, so everything's pretty much set up. I can now go ahead and write my NegaMax or my search function. Okay. So search is depth remaining. I can get rid of this stuff here. So the first thing I need to do is when I come into the search, I need to first check to see if a player has won the game. So basically what I want to do is I'm gonna do a quick check here, which is I'm gonna call check win. Now the only thing is I need to know what column the last piece was placed on in order to do that. Okay, so with my search function, I need to use the depth remaining, and I also need the column that I last placed the piece at. So in my search function, I'm going to pass in 4, and I'm going to pass in I, which represents the column. So now I can say if check win column equals states, oops, I'll just say, okay. So there's a few ways I can structure this. I'm just gonna go with it. If we're not playing, that means the game's over. So now I can add a bit more code here. So basically if, now I could call check win again, but that's a heavy function. So what I'm gonna do instead to make my program run a bit faster, I'm gonna cache this. So I'm gonna say let game status equal check win column. If game status is not equal to playing, then I come in here and basically I say if game status let me just quickly take a look at the check win function. Does it return? Yeah, it does. Okay. What's the game state? Okay, here's game state. Does that actually change? Okay. Okay, so this is a bit clunky the way I have this set up, that I have this global, this is why global variables are bad, right? Whenever you have them, they're sprinkled all over your code and you don't really know what they're doing. It's much better if you have local variables in functions. I'm not gonna go and change this right now, but this is a sign that my code structure isn't as good as it could be. That I have this game state, and you can see where it becomes confusing because I have this game status variable, which is really, really similar to the game state. So maybe I need to, I'm just gonna double check that I don't need to change this. Yeah, okay. Yeah, it's fine for now. Okay, so I have game stat. I'm just gonna say status because game status is too similar to game state. So status. Okay. So if status equals state.raw, then I'm going to return 0. Else, I'm going to return. So basically, it's the game over condition. Okay, so one issue that comes up when in our search, if the game has been won at some point in the tree, there could be many places where there's a game-winning condition. So a scenario that comes up is maybe the search can find a winning move in one move, or maybe it has to make 5 moves before it gets to the winning move. If I just return a score of 10, then the search is going to basically not know which one of those two situations is better because they both result in a win. But we know that getting a win sooner is better than waiting and delaying. All right. So one of the things that you can do is basically return the depth remaining. So in other words, the depth remaining, if you return it, so essentially you're returning the remaining depth, and that'll mean that at the higher nodes of the tree, that value will be much larger than if it was at the lower ones. Now, it might be a bit confusing that I'm putting this minus sign in front, but basically the NegaMax, whenever you return the values, you have to negate them. It's part of the algorithm. But essentially what I'm returning is the depth remaining. So let's say I start the search with a depth of 8, okay? If I can find a move in my first move that wins, that's going to return a value of 8. So I'll have a score of 8. Then if I find another move sequence where I've looked 5 moves ahead, in other words, I have 3 moves remaining, that'll return a score of 3, which is less than 8. So I'll take the faster win, which is what I want. Okay, so I have that taken care of. So now the next thing I need to do in my search here is I now need to basically loop through all the moves, make them, grab their score, and then unmake them. Okay. So I'm going to basically copy this code here. All right, so for each column, if the column is available, then I'm going to try making a move there. I'm going to then get this, I'm going to search for the score. If the score is better than best score, then I'm going to update that. And I don't need to worry about a best move. So I can actually simplify this a little bit. I do need a best score though. So I'm going to say let best score equal negative 1000. So just a large negative value that I could never get in my game. And I'm going to say score equals math.max best score search. And instead of passing in this hard-coded value of 4, this is where I want to say depth remaining minus 1. And I want to return the negation of that value. Or sorry, I want to grab the negation of that value. And I want to then return best score here. Okay. All right, so I think this might be ready for prime time. Let's try it out. Okay, so it's not quite ready for prime time. I'm getting a lot of game overs. At 307, line 307, okay, it's not good. Okay, let's take a look at line 307. Why would it be getting printing all these game overs? If count is greater than 4. Okay, clear to check. All right, now because I'm doing this big search, one thing that I do have to watch out for is that all of these print statements are going to slow down my computer. So I probably need to remove any print statements, any console logs that I don't want. So let's, oops. All right, it doesn't look too bad. Let's try this again. Okay, so I know why. So this is one of the issues with recursion. And you can see here my CPU usage is blowing up, right? When you call a function repeatedly over and over and over again, you basically are locking your computer in an endless loop. So you're gonna your computer is going to just look whatever core or thread that's running that program, it's going to completely lock up any resources it can get until that recursive part finishes. So this is one of the reasons why you typically don't use recursion as a technique when you're writing professional level quality programs. But when writing games or simple exercises, it's actually a lot of fun to do recursion. The reason this doesn't work is because I forgot when you do recursion, you need to add what's called the base case, and that is the situation where the recursion stops. Right now, my recursion will keep going forever. In other words, it's not respecting the depth remaining variable. So what I need to do is I need to have an else if depth remaining equals 0, return 0. And that's it. That's the one thing that was missing, and now it should work a lot better. So let's see. Okay. Uh-oh. Okay, so player, okay, so we have some coding errors here. Okay, player to check. Yeah. Okay, let's try that again. All right, player to check. Okay, so it's not playing particularly well right now. Okay, I also need to, it's not resetting the game as well. So a few things I'm gonna have to do when I reset the game. So that is in my get mouse position. So this is where I set the game state to playing, the player equal to 2. I want red to start first. I think that might be it. Okay, the other thing I need to do now though is I need to remove a bunch of these console logs because I really want to add some information about each move that's being made to make sure that I'm getting the best score. So console log. Okay, that looks good. And now let's go up to my, where I'm starting my search up here. And basically I'm gonna print the column and I'm gonna print the score that it got. So I'm gonna say console.log and I'm gonna say column plus I plus score. Okay, let's try that. Okay, so I got some kind of syntax issue here, column plus I. Oh, yeah. Okay, there we go. Okay, so when I look at the console, I can see here that it's returning a score of -1,000. So that is not good. So score is -1,000, and that's -100 there. So somehow this best score is not being updated. I see. So that shouldn't be let score, that should be best score. Okay, here we go. Okay, so this is more like it. We're seeing scores of 0. It's only looking for half moves ahead. So that's not very far. So it's not gonna really see anything. I'm still seeing these drawing. Okay, I gotta get rid of these drawing piece. Okay, get rid of these. Okay. So that's not particularly good because it should have seen, because it's seeing a score of 0, it wasn't realizing that if it made a move there, it would lose. So that column shouldn't have returned that score. Okay, so there are a couple issues, and these are kind of intricacies with the min-max algorithm. But basically, when I call the search function, I need to negate the value that's returned as part of the NegaMax. And then when I come in here, the way I've structured this, when I return the depth remaining, I need to negate that as well. So in other words, from this first node in the tree, they're going to make a move and see. And if they won, if that move is a win, then basically because I'm negating it here, if I don't negate it again as well here, then it ends up being a negative value. So it basically means like, I think I lost. So this is one of the things working with recursion and this type of algorithm, it is kind of tricky. So I wouldn't, it's a little bit, this part is a little bit tough to follow. To simplify it, you could write two functions. You could write a min and a max. One player maximizes, one player minimizes. And then you wouldn't have to do all these calls where you're negating things. But it is more code to write. So I think this is still actually easier. All right, so now when I run this, you can see when I try to go for an actual winning position. Okay, hold on. What did I do wrong? Did I not save it? Okay, let's try that again. Okay, so what you can see here is it's actually getting some real values. So in that last one, it realized that if it didn't make this move here, that it would then lose the position the next move, essentially. So that's why this column gave it a value of 0, right? All the other columns returned a negative value, indicating that it would lose if it played them. And this was the only one with a positive score. When the player is computer searching, if all of the columns come back negative, then the computer thinks it's imminent that it will lose. So now I can try to beat it. I'm guessing I can. Yeah, I need to block that. Okay, so I lost. So one thing that's kind of interesting is what we should do next. I want to do is calculate how many positions it's actually searched. So what I can do, I'm going to add another global variable. I'm going to say var total positions equals 0, and I'm going to make sure that this gets reset every time I place a piece, basically. All right, so in my search function, I'm going to, every time the search gets called, I'm going to say total positions plus plus. And then, when I do my search, I'll basically say console.log total positions. Okay, and before I start my search, I'm going to set equal to 0. So this is kind of an interesting thing. I can see how my program is performing in terms of speed. So there we go. It just searched 19,000 positions, 18,000. And one thing you'll notice as the game progresses, it'll eventually start searching less and less positions because there will be less space on the board for it to play. All right. See, it's gone down now to, that last one was only 6,000, 8,000, 5,000. You can see the pattern. Okay, there we go. I lost again. Great. So the next thing I can do is I can now try increasing the depth. So right now it's using a depth of 4. what if I tried to search a depth of 8? Let's see what would happen. So as you can see, the program is hanging, and now you can see the scores starting to come in. And that's because a search of 8 is a really difficult search in terms of the time complexity for the algorithm. It takes it a while. So you can see here, wow, I searched a lot of positions. What is that number? 44,131,631 positions on the board were searched. So quite a bit. It is kind of slow though. Now by setting it to be a larger search depth, that means the program should play much stronger Connect 4. Okay, so what I can do now potentially would be to optimize the program. I could try to see areas where my code is inefficient, and I could try to increase it. Now one area you can see here is when I test for a draw, basically I am essentially what I'm doing is I'm looping through all the positions on the board, and I'm using 2 for loops to do this. So this is actually a really inefficient piece of code here. There's a really simple trick to check for a draw. And all I need to do is create another variable called var move count equals 0. And let's see here. So I'm just going to make sure it resets itself. And now whenever I make a move, in my make move function, I'm going to say move count plus plus, and unmake move is going to subtract 1 from it. Okay? Now we know that there's only 42 positions on the board, so a draw will occur after position 42. So I can now go and I will comment out this code. And instead of if draw, I will say if move count equals 42. So this should definitely, well, we'll see how much it speeds it up. Okay, it's still pretty slow. So there you go though. I mean, those are the types of things. I think it did run quite a bit faster using this. So 8 what are called ply, it might be a little bit too, too much right now for, it's not bad though, because you get to watch the scores come in and you get to see the thinking. So basically that last position, it said that the program said that if it moved to column 0, it would lose the game. If it moved to column 1, it didn't know. And if it moved to column 2, it would lose. If it moved to column 3, it wouldn't know. If it moved to column 4, it would lose. Column 5, it wouldn't know, and column 6, it would lose. So that's pretty neat that you can see that it's able to calculate these positions. So let's try this. Let's play a game. Right now, I still have that old AI set up. So I can actually have it play against the old AI. And to do that, I just need to make a few small changes. So computer turn was the old code here. So right now, if it comes into the playing state after a piece is placed and it's player 1, then it is going to use the search. I'm going to now do an else. So I'm going to go else if game state equals state.playing and player equals 2, then I'm going to do my computer turn now. And I just need to verify that the computer turn function is still, seems good. So I come in here, I loop through everything. If I can, I make a move. I check for the win. If the game state, okay, so if the game state is red wins, but the computer's gonna play yellow though. So I'm just gonna say is not equal to, okay. I'm gonna go if the game state is either red wins or yellow wins. Okay, I place the piece. for a move for the human. Okay, so in this case, I actually do need to know who this one doesn't matter because if I move, only I can win. This part isn't going to work properly though, because it's going to place the piece. Yeah. Okay. So I actually need to use my old hacky code for this. Yeah, this is a little bit, okay, so I need another variable. So let opponent equal, and I'm going to say player equals 1, then the opponent is 2, otherwise it's 1. Okay, so I place the opponent piece. I'm not going to unmake it. I'm going to reset it to the original piece, and the game state after move, I get that. Okay, and then the game state after move. Okay, this is still gonna work. All right, so I can now test this out. Basically, I could just go and do computer turn. So I could go like this. I won't do my search. I'll just say go computer turn. Okay, let's try this. Uh-oh. 245. Okay, I'm missing a bracket. Okay, there we go. All right. So let's just try to play and make sure it still can play reasonably well. Okay, I win. Okay, so it appears to be working properly. So let's actually try now simulating a game. So all I have to do is I'm going to remove this code here, and I'm not going to use the computer turn. I'm just going to have it do the search. So right now, the red player is going to play the poor AI, and the good AI is going to play the yellow. So let's try this out. Now, of course, I have to start off, so I'll start it going. So now yellow is calculating, and that is our new AI looking 8 ply deep. And we can look at the scores. So it sees that there's a couple moves if it makes, it could lose the game. Okay, so it's not seeing any wins yet. If it sees a positive value, then it's actually going to see a winning move. It's not seeing any yet. Oof. Now, one thing we notice is it starts to move faster because there's less positions available. Okay, it ended up in a draw, that game. So let's try another one. It's pretty interesting. Now, one thing that the AI, even though it searches fairly far ahead, it doesn't have any strategy or other sort of attributes that will allow it to try to pick a better move other than just a winning condition. So that leaves it somewhat blind to tactics. Oof. Okay, there we go, yellow won. So that time the AI, the search function won. And when we look at the search, we can see that it didn't at any point, it always had negative values. And then all of a sudden, it came in and it had a positive value and took the win. Now, another thing to keep in mind is that the stronger AI is playing the yellow position, which is a disadvantage. The red player has the advantage when they go first. So that does even things out a little bit. Another thing that I'm doing right now as well is if the AI doesn't see a good move, it'll always play the first column. So that's maybe not the best approach. Okay, it won again, it was victorious again. And here, if we look at the search nodes, we notice that on the second last move it made, it saw a winning value at depth of, basically a depth remaining of 6. So essentially 2 moves ahead, 2 half moves ahead. And then when it came, it saw an immediate winning move. Okay, so let's try one more. Last game, okay? So it's searching. And that is something I could do. I could randomize. When it has a bunch of values with the same score, I could add some code so that it would randomly pick one of them. Because, right, it is kind of boring seeing it pile up on the first column, and that's probably not a good strategy for it to play that way. Okay, and yellow wins again. Right, okay. So the last thing I need to do, let's just do, let's quickly do some Git. So I'm going to go to my repo and okay, so I need to use this command here. So git checkout -B is the option I need, and then search improvements. Okay, so now I'm on my new branch and git status. So I want to say git add game.html, and now I'm going to commit those changes. So basically I added a NegaMax search to the AI. Okay. And now I'm going to say git push -u origin So I'm going to push my branch now to the to my GitHub, and there it goes. So I can now go and do a pull request on my GitHub. Okay, hold on. Okay, so we can see here right away I have a pull request, or basically a push branch. So I can now do a pull request. And we can see all the changes that I made, quite a few. So I can go over those, make sure that they're ready, and then I can fill out my pull request. Okay. All right, and now the pull request is there. There's no conflicts, so I can now go ahead and merge this. Okay, and then of course, once it's been merged, I can now delete that branch because we don't need to keep that branch around anymore. And at this point, I can now go and take a look at my code once again. And I'm on the master branch, and I can see that I just updated the game HTML, was updated 2 minutes ago. So that should have all my changes. And now for my local repository, because I've now merged this back in, I should go git checkout master and git pull origin to basically update and get the latest changes on the master branch. So I'm now working on the master. All right. So I'm gonna end things there. So I hope you guys have had a good semester. You know, my goal was to try to really share a passion for coding, try to encourage you guys to code every day, work on your skills. You know, that little extra, coding every day can really make a big difference. And we also did some career prep stuff. So please make sure you guys finish up those resumes. They need to be in a good state to finish this course. I will be providing more feedback through the D2L Dropbox, so I need to get those fixed ASAP. And if you're having any issues with your personal projects, please reach out to me and I will assist as much as I can in helping you guys finish those up. And one last thing to mention in terms of the personal projects, I'm not necessarily looking for something that is done and polished and perfect in every way. I really just want to see that you've been working on stuff and you have something there that you can now move forward with and continue to improve and develop. And that's really the goal. It's not to come out with something that's completely polished and done. In fact, if you have several bugs, that's fine. Those are things that you can work on in the future. Okay. So anyway, I'll talk to you guys later. Please, give me a shout if there's anything I can help with over D2L or email. And have a great day.